Ben Dewey is going to be doing the presentation. He'll be talking about JavaScript applications and how to test them. Ben is one of our MVPs, and with that, I'll pass the control over to Ben.
All right, cool. Thank you. So I guess I want to start off a little bit with just a bit of a question, kind of by a show of hands. How many people are writing JavaScript? And so this is Link. I mean, obviously, I was meant to be a little bit of a joke. I don't know if any of you raised your hand at your desk, but the idea is I do want to make some of this interactive. So if you guys feel free to chat in the chat window, if you have any kind of questions or if you have any responses to anything, feel free to just throw that in the chat window. I have it open and I can see things coming up. Because the reason I asked that question was really because everyone's writing JavaScript in some way, it seems like. Traditional web applications had a little bit of JavaScript, and mostly they were HTML. We had databases and back-end server processes that were handling most of it. But nowadays, it's kind of flipped, and there's way more JavaScript on the client side than there ever used to be. So we need a way to test this. As far as types of testing, there's a couple different ways, and one of the ways that probably everyone is doing is just considered manual testing. So the problem with manual testing is it's not really sustainable, right? Over the long term, if you can't manually test the same thing, as the application grows, you have to go back there, and when it comes to regression testing, you're never going to catch all the bugs and features that you want to try to catch. The next one would be, the next one that we can't do really is QA and UAT testing. Obviously, we should still be doing this anyways, but this doesn't help us as developers because it's way too late in the cycle, and generally it's a cause of panic. If you start getting a lot of bugs in the QA and UAT cycle or phases, then that's just going to be hard on the team to go and implement all those and update those. So it causes a bit of a delay, one in your mindset, but then also in the overall project deliverable. So there's three other areas that are kind of left, and those are really what I'm going to lump into as just considered automated testing. So things that are going to run automatically in order for you to build your application. The first one I mentioned, or I want to mention, is compilation. Now, when you're building C# applications or server-side applications, you have the ability to have compilation. This is more of a feature of statically typed languages. JavaScript is not a statically typed language, so unfortunately you don't get the benefit of compilation, and so luckily there are tools out there, automated tools out there, that allow you to do some form of compilation of your JavaScript. And that's really just a first step, a basic step to make sure you didn't put some incorrect syntax in or put a semicolon in the wrong place. The next one would be unit test. This is really just the idea of a fine-grained piece of code that you wanted to unit test. Something like the example that we're going to be using later on, which is just a calculator which needs to add two numbers together. That's just a distinct piece of code, some form of a module, and I want to test that, and there's no real front end to it. The next one would be integration tests or end-to-end tests. Generally, these are going to be a little bit slower, and they're going to interact two sides. They're going to interact the UI side, but then also the back-end side. So if you have a database involved or a service involved, your integration test might actually go through and communicate with those together. So we're going to cover all three of these today. But I want to go over a little bit of just why would you automate your testing anyways. There are some good points already, but there's a few others that I wanted to highlight. The first one, and this is actually my favorite, is it's going to have you as developers slow down and think about your code. All too often we get a feature request, we go ahead and we send it in and we write the code to click some button and have some data pop up, right? But it's nice to slow down and think about, okay, how would I test this? How would I, if I didn't have a front end and I just wanted to think about an API layer, how am I going to test that? If you're also doing this services part as well, it gets you to kind of think where is the surface area going to be for your services, and where is that line going to be? How granular am I going to call into the services? But overall, that process of slowing down is very helpful. It helps you create a better architecture in the long run, and also helps you understand the problem and the edge cases a little bit more. The next one is a shortened feedback loop, right? if you are in the process of writing code, and if you're writing code on top of a legacy system, you want to know right away that something has broken, and the sooner you know that, the better. Back before when we were talking about the QA testing, how that's a little too late in the cycle, that would be, production is the most extreme, but QA is the other extreme. It's far enough away that you've probably forgotten the code that you wrote at the time, and you don't really understand that problem as well as you did when you were actually knee deep in it writing the code. So you want a short feedback loop that gives you real quick updates to let you know that the code you just wrote has broken something or is different. The next one is fear, right? Everyone talks a lot about refactoring. We want to refactor our code when things change, and we want to keep it up to date and modify it. But the problem is, if you don't have unit tests to support that, you're really just refactoring blindly, and you don't have much certainty to know that the changes you're going to make aren't going to affect the system in some way. So you want to get rid of that fear, and having those tests allow you to make changes and then the tests are there to help you understand whether those changes actually broke anything. Okay. The final one is that it reduces bugs, right? Overall, we want to have less bugs in our system. The unit tests are going to be there to help maintain, bug-free code on all layers, and then you have the end-to-end test that you can run to ensure that things haven't broken and you haven't had side effects. As far as now we know we want to do testing. There's a lot of benefits to it, and we want to try to include this in our application. So the first one I want to talk about is compilation testing. Now, I'm going to do most of this in Visual Studio, but all this code and all the demos that I have here are going to be available on the command line as well. A lot of them have roots in the command line. And then these are the first examples I wanted to talk about. So the first one is JSLint. This is originally just a JavaScript compiler that checked for any syntax errors and any issues in your JavaScript. The problem was that JSLint was far too aggressive. So another product came along, which was JSHint, and that's a much more practical fork where you can actually use this as a bit of a compilation engine and have your test completely clean of any issues as you write your code. The last one I want to mention here is JSCS. This is a JavaScript code styling engine, which allows you to just verify that you put your team kind of style guidelines for your code are maintained. Here in the chat window, I want to kind of just see here if anyone knows what's wrong with this code here. Okay. Well, Mike had missing semicolon, which is sort of right. So the parens is the return statement. I'm not sure if you're getting it exactly, but basically the parentheses and the left and right, those are actually unreachable code. That code's never going to be reached because return, due to a feature called ASI, the automatic semicolon insertion feature within JavaScript, it'll automatically add a semicolon to the end of this return statement, and this code will then never get reached. So it's going to return undefined rather than actually returning the proper result. So this is something that's great for JS compilation or JSLint to come up with. Actually, all the unit tests would come up with the same error. But we'll run over to Visual Studio here and show this in action, right? So here we have a simple Visual Studio project. We just have an index.html for our calculator, and then we have a scripts folder which has a calculator JavaScript file, but also our main application code, which is really just hooking up the text box and the button. So here we have our add method, and inside of there we're returning left press right, but we put it down on an extra line just to trim up some space. And when we save our file, we have Visual Studio enabled to run JSHint whenever we save our files, and here we have an error message that says missing semicolon, and then also expected an assignment or function call, but instead saw an expression. So it's basically saying you just put an expression on a new line by itself. But regardless, these two messages kind of go together and tell you that you have an error in this code, and then when we fix it and save it, then our JS hint has now gone away. Now, in order to add this to your Visual Studio, you need to have a tool called Web Essentials. If we go under Tools here, into Extensions and Updates, and then Online, you can search for Web Essentials. And this will give you a plugin that you can add that I've already added here. So it's already been installed for me. Okay, so here I've already installed Web Essentials 2013 Update 4. And what that does is it brings over a lot of cool features, but also this menu up here for Web Essentials. This supplies all of your the settings that you're going to use for Web Essentials. I can create solution specific, or I can use global settings that will allow us to tell us how we want JS hint to run. I can edit this file, and it will give you IntelliSense to tell you what all these mean. So over here, curly, it's going to require curly braces for every new scope block. So something, if you have an if statement and you want to return a variable, this curly will tell you, always put parentheses around your return statements and then, or around your if blocks, and we'll throw a compilation error if you set that to true. All right. Under options, you can configure these a little bit differently, and I like to do this on some of my projects. Under options and then Web Essentials and then JavaScript, there is the linter, which is essentially what I was calling the compilation of JavaScript. It's really, they consider it called linter because of JS lint. But you can select here where you want the results of JS hint to go. And in this case, I've selected error. It's going to default to warning. So if you select error, then it's going to actually not build your application if you have those errors, and kind of puts it right there in front of you to tell you to fix your JavaScript before you kind of go on to do anything else. The next one I wanted to talk about was unit testing. If we jump back over to our application here, we have essentially, let me just start our web server or load up the page here. We have a calculator here, which has two fields, a left and a right, so we can add 2 plus 3, and we can set it equal to 5, right? So what we want to do is we want to unit test this, and there's a couple different ways in which we can do that. This here is a first example of a tool called QUnit, and QUnit essentially is just a simple unit test framework that was built by the jQuery team that allows you just to kind of write simple unit tests over any JavaScript code you have, and then send that out through a browser, right? So jQuery kind of originated in the browser, and everything within QUnit kind of ran in the browser. This is comparable to what a lot of the newer frameworks are using, which is the Node.js platform, which is more of a JavaScript engine and that runs on the console within Windows or any of the operating systems, Mac or Linux as well. So this here is an example. Basically, you're going to start off your unit tests by defining just a QUnit test object. So here we have test, and then you supply a name for your test. So we're calling this a calculator add test. And we're saying it should add 2 numbers, add the number 2 and 3. And in order to write your test, we're going to follow a pretty well-known convention called arrange, act, and assert. All right, so that's the 3 steps that you're going to use to write a unit test, and they loosely map to a given, when, then sort of structure, which is considered which is called the Gherkin language. So the first thing you're going to do is you're going to arrange your test, and you're going to tell it, what sort of expectations you have, what variables you might need. If we need some sort of class defined or objects defined, we could do that all in the arrange statement. The act is where we're actually going to call into the function that's going to be doing the work. In this case, we'll call into our add function, passing it the numbers 2 and 3. And then the last part is going to be our assertion, where we're going to assert that the result from calling our function and our expected value are the same. And you can have an optional string in there at the end that just tells you that you can define saying adding the 2 and 3 should equal 5, and that'll be included in the failures if there are any. So let's go over to the demo and we'll show how that works. Over here, back to our calculator application, we have, as I mentioned, we have an app class and a calculator class. Our calculator class has, inside of it, it has a little bit of a wrapping immediate function, but essentially the calculator class has an add function, which you saw before takes a left variable and a right variable. If we wanted to write a test for that, we can go into our test folder. We created a file called calculator.tests, and we just put in here the same code that we had before. We're going to say calculator.add and put 2, 3. Now to run these, there's a couple different ways to run these. The first way would be to run it in your browser. So here we have another HTML file set up called our testrunner.html. And this has a couple things. It has 2 divs for our QUnit and our QUnit fixture. QUnit is going to be where it's going to write out the information about the tests, about how many tests passed and how many tests failed. And then the fixture is going to be the place where it's going to execute code if it needs to do anything on the DOM. It's going to put it in there, and then it clears that out between every test. As far as the JavaScript, we need a reference to our QUnit JavaScript file. This is really our library or our framework that we want to use. You have to include the code for your application. So I'm just including our calculator class because I know we're going to need that. And then you also have to include the actual tests that are going to run. All right, so calculator.test, which is our test file. Now, if we go into our browser and we navigate to our testrunner.html, then this is going to run all of our JavaScript tests, and you see we have our one add test, and it's green because we successfully added 2 and 3. If we want to kind of purposely make a mistake in here, just to test this out, we can do something like, instead of adding left and right, we can add left and left. And now, if we refresh, you'll see we have a failure. So it tells us we expected 5, but the result was 4. And then it tells you the line of code where those errors came from. So this is really what jQuery started with as far as what it used for unit testing. It had the browser-based test runner, and it would run this. It could run this in multiple different browsers, and this was their way to run their test suite across all the different browsers. Was they actually would launch the browser and run it. So there are other ways to run these tests. The next way would be to use Visual Studio's Test Explorer or Test Runner. And in order to do that, you'll need to install a tool called Chutzpah. If you go to Extensions and Updates, then I should have it installed. Install Chutzpah Test Adapter for Test Explorer. And what this will do is allows you to hook in your JavaScript test to the Test Explorer. You can also get the context menu, which gives you right-click support, but that's a separate plugin from the Test Explorer there. Once you have that Test Explorer installed, it should automatically start finding your unit tests. And if you want to run them, you can just use the commands up top to say run all, or I can right-click on them and say run selected. So I can say run selected. Now this is going to run our test, and now because it's left and left, we should get an error message over here as well. Okay? So we see we have a failure message, adding 2 plus 3 equals 5. It failed. It did not work. So we can go in here and we can fix that. Save. And now run this again. All right, and now we have a green test. So this is a real simple, low-friction way to get some tests in. Oftentimes, you're not going to, you wouldn't use this to test something with a lot of dependencies. But if you had a little helper class, maybe you could use this to build up that helper class. The next way that I wanted to show as far as the QUnit testing was in the command line. actually, sorry, the Visual Studio through the Test Runner Explorer. So this is Visual Studio the one way through the Test Explorer. The next way would be through the Task Runner Explorer. And the Task Runner Explorer is also an extension for now. It's an extension that's provided by Microsoft that mimics its preview product that's coming out in Visual Studio 2015. So Task Runner. So I have this installed as well. So we have this thing called Task Runner Explorer created by Microsoft. And the beauty of this is it's going to look at your gulp or grunt files depending on what you use in your system. In this case, I have a gulp file set up. And what we do with gulp, this is just JavaScript code. We essentially say we are going to require a component called, or a module called gulp QUnit. And then we're going to have a gulp task called test, where we're going to send our test runner HTML into this QUnit function, and that's going to process it using QUnit and then return our results down here in our task runner. So I can go ahead and double click on our tests down here in our tasks, which again maps to that task up there. It's going to run our test, and you see here we have a check mark that the QUnit assertions all passed and they were successful. All right, just to kind of show what that looks like red, again, if we change this to left and we run our tests, then we should have a red result telling us that our test failed. All right, and you can even look at this error message here and see, okay, should add 2 and 3, expected 5 but was 4, right? So these should point you to the general place where your test failed. If you named your tests well and you knew that the calculator add test was in the calculator test, then you'd be able to track that down pretty easily. The last way is using your command line. So here I have just a regular command line. And I'll go into this folder. And essentially with the command line, you have to make your test code into QUnit code, or sorry, Node.js code. So Node.js has built-in support for what the require function, which can require any module that you need, and then you can also require your own internal classes as well. The version that runs in the Test Explorer over here does use a browser. I'll get into that a little bit later. It uses the Phantom.js browser, which is more of a command line browser that does some simple manipulation of DOM elements. So that's the basics of unit testing and the kind of different ways in which you can run unit tests or specifically QUnit tests within Visual Studio or on a Windows machine. There are other types of unit testing frameworks as well. So for Mocha supports a TDD version as well, which is very similar to QUnit. You have here a suite called the calculator, and then after that you just have tests. So we can have this test method, and it says should add 2 and 3, just like we saw before. Instead of the arrange, act, and assert, we just have a basic action inside of an if statement. Basically, the way all these test runners work is by throwing exceptions. This is how all test runners have worked in C# and Java and many others. Basically what the test runner is going to do is it's going to run a select bit of code with a try-catch around it, and if it ever receives an error message, then that error message gets filtered up as a failure or a failed test. What we have here is Mocha by itself without using Chai. There are no exception or assertion frameworks built into it, so you have to do all your assertions manually. And the easy way to do that is just to throw an exception. And so we use just a normal if statement to do some conditional logic, and then we throw an error if the logic did not succeed. Okay? And so that's what we're doing here. We're just kind of saying if 2 plus 2, this should be a 3 here, 2 plus 3 doesn't equal 5, then we throw an exception. The other style is a BDD style, and it actually is no different except for the way the functions are named. So before this was called suite, and the it tag was called test, And now we're saying describe the calculator, and then it should add 2 plus 3. Now, this here is designed to be much more readable, so that you can read together the describe a calculator and it should. So if you're kind of into that fluent naming where you can read the variables and the strings together as one full sentence, this might be a little more appealing to you. I mentioned a little bit about Mocha and Chai going together. And this is where you'll see now, instead of it being complex with our if statement and then throwing an exception, we get the benefit of having the expect function, which we can put into our action, and then use a fluent interface to describe how we want to verify that exception or expectation. So in this case, we say .2.equal5, and there's many others that provide that same sort of fluent nature. And so, like to be truthy is one of their ways that they describe something that's JavaScript representation of true or not null, and many others. Next one here is Jasmine, and Jasmine uses the same BDD style that you saw in Mocha. There's actually no difference here between the Jasmine code and the Mocha code with Chai in the way that you would write a simple test. And all of these are going to run in a similar way. They're all going to run within the Visual Studio Test Explorer, like I showed before. And they're also going to run on the command line and in the browser, like the other ones. I wanted to speak a little bit about testing and the testing drop-off, right? And the reality of what happens in most projects that get started with unit testing or testing in general. Testing is like going to the gym, right? You need to keep up with it. You know it's good. But sometimes it's hard to get there, and you know, especially when a big deadline comes up, you might skip it for a little bit and throw away the tests. But at a certain point, and then when you try to go back to it, it's extremely hard to go back and actually start writing those tests again, or keep the bar green. You really have to maintain your test and keep the bar green as long as possible in order to maintain a clean project. The problem is, as well, some of the tests become difficult. So they start to, what they call, the tests start to cry wolf, right? Your unit tests, all in all, are going to, when you start making a simple change to one area, your test may start failing all over the place, and you don't know, they're not necessarily representing a real production bug. They're more bugs in the test code itself. And so this is just a common thing that happens because people aren't refactoring their code enough. So essentially, you want to treat your test code just like you would any other code, and you want to refactor it to have it make more sense and to be more clear about what it's actually doing, and not just be, you know, procedural like test code. This is also something that makes it a little difficult with some of the end-to-end testing suites that they have that do more of a record and playback style approach, where those become very brittle and fragile and often run into this problem where the tests start crying wolf and become difficult to maintain. I like to kind of use a little bit of analogy about the tightrope, a tightrope walker. So if a tightrope walker is walking along and they've never fallen off before, they don't really have much respect for the net that might be down there to save them if they fall. Right? It's not until they actually fall off the tightrope for that first time and the net does catch them that they can really understand the power of having that net. So I really like that as an analogy for unit testing, because it seems to reign true with a lot of, you know, people I've seen when they get started with unit testing. They don't see a lot of the benefits, and they're more likely to drop off when they see when they start hitting some of the challenges of unit testing. And it's not until you actually fall off of the tightrope once and have one of those unit tests catch you with an error, and not specifically just any error, but an error that would have really been a bug that you didn't know was there and that unit test alerted you to. That moment that you actually have that happen, you begin to gain a much higher respect for the test and the test being there. I like the analogy in a lot of ways because also the net itself can sometimes represent the the scope at which, if you consider the tightrope being the one line or the one rope of production code, your unit tests really need to cover a larger area than just that single rope does. So when you're thinking about unit tests, you do need to be prepared to have a greater level of unit tests as far as lines of code than you would for your production application. So I did want to stop here a little bit just for some questions, if anybody has any questions. But if not, let me just do a quick time check. I would like to go on to do a little bit of a TDD by example, so we can show how things are going. I do have one question here about what version of Visual Studio Web Essentials is this supported in as far as the JS hint. I had to look that one up. I think JS hint's been there since one of the earliest versions. All right. So now to go into a little bit of a TDD by example and to bring in our last bit of testing, which is our integration testing, I want to do an online bill pay scenario, right? So I'm going to go onto my banking site and I want to put in a company name and a bill amount, and I want to hit pay bill, and that should ultimately deduct from my balance or my account balance. Okay, so that's the scenario we want. We want to describe paying a bill, and then it should decrease my balance by the amount of the bill, right? So it's a flip an amount to a negative and subtract that amount from my total overall balance. So we're going to take here a bit of an outside-in approach. This is a common approach that you would see when you're doing full TDD and end-to-end test with end-to-end testing or integration testing. First thing you're going to do is you're going to write an external integration test that's going to cover the UI and the scope of the application, and then you're going to go in and you're going to write little unit tests across your internal code and modules or controllers to verify that everything works correctly. All right. So let's jump in. We're going to do our outside test with a framework called Protractor. This is based on the Selenium WebDriver framework, and uses browser automation to run a browser and actually automate the browser by clicking it manually. And it has an API that works well with Angular, so that's what we're going to use for this. For our inside tests, we're going to use Jasmine plus Karma, which is our test runner that's going to actually handle running our unit tests within a browser as well, but more from an automated command line standpoint. All right. So over here we have our banking application. Just like before, we have our task runner, and this is all based on a gulp file that's going to be running all of our tests. So the first thing we want to do is just start up our web server. So I'm going to double click on web server, and that will start that. Oh, let me stop the other one first. Okay. So here we have a tool that allows us to add money. So I can say initial balance, say $250, and then I can pay a bill to Amex for $100. And then when I hit pay bill, it should deduct. Now it's clearing the values out, but it's not actually adding any deductions here. So that's really what we want to do. We want to populate our bill to and our amount, and then our value here should get updated in our balance. So to start off with writing that as an end-to-end test, we have our test folder here. And inside of here, we created a file called billpay.uitest. And I use the UI test as a way to tell Gulp and some of our test runners, it's a way of filtering by file extension or by file name, what tests need to be sent through Protractor and run. But what we have here is the same arrange, act, and assert that you would have seen before, except we have this over, and it's also using Jasmine the same way with our describe and it blocks. But then in the code here, we have a few other things that are provided by the Protractor API. One of them being the browser function, which allows you to interact with the browser and click on items, but also navigate using browser.get. Once we get this URL, we're going to say element.byModel and say build2, which is going to be the model within our controller, the object within our controller that we want to find the element associated to. And then we'll say send keys. Now, what's nice about this element by model is that Protractor is designed to wait for that element to appear. So you don't have to wait. You don't have to worry about the application being slow to load. It's going to start up when the page starts up. It's going to, you don't have issues with the test failing because the item hasn't loaded yet. Protractor handles that automatically, and will wait until that element appears on the screen before issuing a failure. So here we're going to set our two fields. So we'll find the elements by model, and we're going to set some text in there. And then we're going to click on the button that says bill pay, and then we'll evaluate our balance element and verify that the text is equal to negative 100, right? So if we pay a bill of 100, then the balance should equal negative 100. All right. And now if we run our Protractor test or Protractor task, this is going to launch Protractor, and you might not see it over the screen share, but the browser will pop up. It'll navigate to that browser, type in there automatically, and then verify our assertion and provide the results here. So here's our browser. I'm not actually touching anything. It's running all by itself. It's putting in the value, and it says here it failed. And if we scroll up, we say it expected it to equal negative 100, but it actually equaled 0. And this is actually what you'd want when you're doing this outside-in approach. What you want to do is you want to set up that initial condition and have that outside test. That outside test can fail for the entirety of your inside testing. Okay? So once you've run your outside test and set that up, you want to make sure it's red. And then at that point, you can go on and start writing your actual code. So for this code, we have a controller, all right? And inside of here, we have our controller specs. And you'll see what we're going to do is we're going to initialize a new controller, a new Angular controller, providing it with our own scope that we've defined here. And then we'll set up a few initial conditions here. We did want to specify an initial balance. So I'll set up a new description and amount, and we'll add that amount. So add transaction is going to do our deposit. And then we'll set up in our it statement, we're going to say it should deduct from our balance. So our bill2 is going to be a company name, and then our bill amount being $100. We'll call into pay bill. And then we're just going to go in here and verify that our balance is equal to 230. So this test is going to be, this is just Jasmine, and we're going to run this test in Karma, which is going to be our test runner for just regular old Jasmine unit tests. Now Karma does, just like QUnit, it does need a browser to run in as well, but luckily Karma is going to handle that automatically for us. We're going to have this configuration file, karma.configuration, which tells us what browser we want to run in. So we can tell it we're going to run in Chrome. And now when I run this test, you'll see that it's going to launch Chrome, but it's not really the same. It's not our site in Chrome. It's just the Karma test harness. And it uses the Chrome engine. So once it says connected, it's going to use the Chrome engine in there to run our tests, and then return back our result from those tests. So we have here our failure again for this test. So bill pay should deduct our balance when paying our bill, and it failed. It expected 330 came back, and we expected that to be 230. So here we expected our balance to be 230, but it was coming back as 330, just like we saw in the UI. This bill pay had not been implemented yet. these tests are fairly similar, but you would continue to go down this route, right? I would actually could create a calculator class in here to do some of the adding. I could have, instead of this being a controller test, I could actually have this be more of a bank or a general ledger class or service, and then just run this against the general ledger service where I provide maybe an initial balance to that service. Let's jump over to our actual code, and we'll just kind of implement this and see what this looks like. So here, this is our Angular controller called account controller. We have a bunch of things on here, but right here, the line that was commented out, we're supposed to add the item to the ledger. So now we have a new item added where we're taking the negative of the bill amount as part of the ledger item and pushing that into our ledger. Again, this is a simplified example. You'd probably have many, many more unit tests to cover your one outside test. So after you wrote the one outside test that's failing, you would do this over and over again where you'd have failing unit tests. You'd run the karma test to verify that internal unit test. You could run that over and over again, and 3, 4, 5 times, however many times you would need to have those internal tests running and passing. It still failed. Should be 230. Missed something there.
Did you save the file, Ben?
I do. Thank you. I didn't save the file. That's what that asterisk means. Okay. So now we have our one unit test succeeded. Okay. So once you've kind of gone through that and tested all the different areas on the unit testing side, on the inside part of it, once you're confident again that everything is kind of working and you've tested it, then you can go back to the protractor side and run that outside test one final time. And now if we it'll actually launch the application, click into those fields, type that stuff, and we should actually see the balance get updated. Okay, so now our protractor tests have passed as well. All right. Okay, so let me stop our web server because I want to jump over to another example here. And so that first example was fairly trivial. There wasn't much to it as far as Angular is concerned. It was just basic scope declarations. This here is a bit of a more complicated example where I'm probably going to add a few more unit tests to make this look a little nicer. But basically now, let's actually flip over to the controller. Our controller has validation included in it as well. So we have things like scope.deposit is valid. We want to make sure that we set our form equal to untouched. And if I start this web server, I can show you just how the application looks in comparison to this previous one. But adding this validation in here is something that becomes very tricky and very difficult to test, right? So you want to make sure that the bill amount is required. And this kind of starts setting you down that route that I was telling you where your unit tests become difficult to manage, right? So if we look here, oh, it wasn't this one. I did that one wrong, didn't I? So I was actually going to clean this one up, and at the last minute I cleaned up the wrong one. But you can start seeing how your root scope needs to be a parent scope. You're going to need to load in the template because in order to get the forms element to work properly, it has to be compiled into the scope as part of the actual page scope that you would like. Then in order to get the VM, because we're using the controller as syntax, you have to go into the child scope and grab the VM out of the child scope directly. In order to set those fields so that things like $untouched or $error and the $validation functions become available, You need to use things like set view value, and then you also need to call things like digest, right? So over the course of a real production application, these tests become really ugly, and in order to avoid that and to not have all your tests riddled with that, it's recommended that you always go and you refactor your test as much as possible. So I have here a little bit of an example of what it would look like to refactor a test, right? And this was the original test here, where the arrange was going to set up the elements by bill type, bill to, and amount, and then send some keys to it. And then it was going to find this button called bill pay and click on it. Then it was going to go into here and look for our balance element and get the text from it, and then assert that equaled the -100. All right. This refactored version used a bit of a page model. So we have a pages object that we defined as a helper class, and then we're going to say the page name, which is bill pay, and then this should just be balance. So, and then what we do is we say pay bill, and we pass in the variables that we need. So we're going to pay bill for some company with $100. And what that pay bill is going to do is it's actually going to go in, find the elements, send the keys for the company name, and send the keys for the amount, and then go and click the button. Okay? So now this becomes much more reusable, and I can use this across other tests, and it becomes very declarative to just say, all right, bill pay, pay bill, and provide the variables that I need to it, rather than to have the element binding syntax all over the place. All right, and then finally with balance, it abstracts away the ability to have to go in and get the text property, or let's say it happened to be another type of element that you wanted to get the value. Maybe it was a text box instead of a span or a div. You could get the value from it instead in one place without having to modify all your actual test code to support that. So those are the kind of the three keys, if you will, to the TDD. You want to start with an outside test using some form of automated browser testing like Selenium. In this case, we're using Protractor, which uses Selenium underneath the covers. Once you've written your outside test and you have a failing outside test, then you run your inside tests, and you're going to run those over and over again multiple times until you think that everything looks good. You run your outside test again, and then once your outside test is passing, your features should be complete and working. Throughout that process, whenever you finish a feature, whenever your bar goes green all the way, you want to look to refactor those tests. So look around and see, okay, should we, is any of this code reusable? Is this code not very descriptive? Is it looking like procedural code, or is it looking like, can I read the code and it makes sense to me? Again, just to recap, we use an outside-in testing approach. We're using our end-to-end testing or integration testing with Protractor and our unit testing with Jasmine. Mocking, I didn't show you mocking. I might try to get that in, but you can use a function called Jasmine Spy, which allows you to mock out some functionality. And then the test runner, which we used, which was Karma. And I don't know if I actually pointed this out, but in the second time around, with the second version, when we were running our Karma tests, they didn't actually launch a browser like the other ones did. That's because we were using, instead of Chrome, we were using Phantom.js. Now, I think I mentioned briefly a little bit what Phantom.js is, but for those of you who don't know, it's a headless browser. That's what they call it. It is essentially Google Chrome or some WebDriver equivalent that runs within your command line and will download HTML files and JavaScript files, interpret them on the fly as if it were a web browser doing it, and then return the results from there. So you're able to take Karma, which would typically run in a browser, and run it on a command line as a full command line. That's very useful for things like integration servers, where you might want to have these things run on a per check-in or a daily basis. Some other frameworks to know about, as I mentioned, the Selenium, which is the root of Protractor. There's also Chai WebDriver, which works more with Mocha and Chai. There's Coded UI from Microsoft, that has a record and playback model, but you can also leverage the same style of it exports out to C#, so you can use C# if you create a page model. You can maintain it fairly well. You have Phantom.js, which I just spoke about, and then Slimer.js, which is another form of a headless browser that works more on Safari or on Firefox rather than on the Chrome WebDriver standards. One of the bits I didn't get to talk about is going to be multi-browser testing. So some of these tools out here, BrowserStack and TestSwarm, what they're designed to do is take your application and run it on multiple different browsers and try to solve some of those CSS issues that you might get where it works on one browser but on another. TestSwarm and BrowserStack and even JS Test Driver are built to run on little farms that have all those different browsers installed and verify them each individually. And with that, I think I ran through right at 1 o'clock on the dot.
All right. Thanks, Ben.